This is Foundations in Pre-Cal 10, Lesson 2.6 on trigonometry again. This is part A, and we're starting on page 100. So this problem or this lesson is on, and there actually is only one lesson for this unit, or for the one video for this lesson, is on solving problems. So we're using trig to solve problems. So really important is that the illustrations are only for sketch purposes and they are not to scale. And in fact, you can never assume that drawings are to scale unless you're specifically told that. You cannot assume it. So don't ever make that mistake. Okay. So let's look at this. Carmen is a surveyor who's using a transit to determine the height of a tree. That just means they're using one of these little machine things, little surveyors tripod things. It is placed 5.2 meters from the base of the tree. So we've got that labeled here, 5.2 meters. And the angle to the top of the tree is measured to be 12 degrees. If the transit stands 1.8 meters high, well, that's important now. That means that this height here is 1.8. That didn't write very well, did it? 1.8. That's this distance here. And, and we need to calculate the height of the tree to the nearest tenth of a meter. So let's do some setup here, okay? So setup, the colon. So the height of the tree is going to be, I should label this side of my triangle. Let's make that x. And it is going to be x plus 1.8 because our calculation using trigonometry is just going to find this distance, and we need to add the 1.8 onto it. So we've set that up here, and now we know that that's going to be something plus 1.8, which is going to equal something, and it's going to be in meters. And when I have that filled in, I have my answer. Okay? It just saves you from forgetting about that 1.8. You don't have to keep it in your brain anymore, right? So now we're looking at this triangle. So here's our angle of interest. Here's the hypotenuse. Here's the opposite. And here's the adjacent. So we can see that I'm going to use tan. So tan theta is opposite over adjacent. So tan 12 is going to be x over 52. And x equals 52 tan 12, so my calculator tells me that that equals 11.05294. And then I just leave that in my calculator and I add the 1.8, but I'm going to write it as 11.1 because I'm going to round it as one decimal place. And then when I add that together, I get 12.9 meters as my answer. Okay? Next question, determine the angle the base of the transit makes with the top of the tree. So now I'm going to have to redraw this. So I know that the transit is 12 meters from the tree, or sorry, 50, where did the 12 come from? It's 52 meters from the base of the tree. And the tree is 12.9 meters tall. And we were asked to find this angle. So angle of interest, H, O, A. So I've got, this is tan. So tan theta equals opposite over adjacent. So tan theta equals 12.9 over 52. So theta equals 13.93249. And to the nearest degree, that's going to be 14 degrees. All right. Next example. Ooh, a geometry one. I love the geometry examples. So this one says a circle with center C. There's my circle with center C and a radius of 20 millimeters. So I can I can draw my radius on here. That is 20 millimeters. It touches the arms of angle POQ at points A and B. Now this is really important to know that the radii, which is plural for radius, that CA and CB are perpendicular. And that they don't actually need to tell you that because that's always true. When you have a radius that meets a tangent, it just touches, that means it's tangent, and if it's tangent, that means that it's a 90-degree angle. It's just circle properties. Okay, so those are both 90-degree angles. Now these are both 20, even if we didn't write them down on there. They're both 20, okay, because they're both radius. And the diagram is symmetrical about the line through OC. So I'm going to maybe actually draw a real line. Oh, wait, draw line. There. So that's symmetrical, okay? And if angle POQ is 50 degrees, find the length of OC. So it gives me POQ is 50 degrees, but that's not really useful. What's useful to me is that this angle is 25 degrees, and this angle is also 25 degrees. So I've got two triangles here. They're both right triangles, and they're identical. So what I'm going to do now is I'm going to draw the I'm just going to redraw that triangle. So I'm just going to make a note. It's very helpful to redraw the relevant part of a drawing. Okay, I take away the clutter. So I'm just going to draw the part that I care about. So here I go. This is C, this is B, and that's a right angle. And this is O, and this is 25 degrees. And this is 20, and this is the D I'm looking for, is OC. Okay. Actually, I redrew the important part. That's what I did up here when I redid that drawing. Okay, let's label the triangle. We've got, there's my angle of interest, hypotenuse, opposite, adjacent. Yeah, so my notes, I did the wrong, I found OB, not OC. I did label it that I found OB. That's not what I was asked to find. I did that when I was sick. Anyway, OH, we've got sine. So we've got sine theta equals opposite over hypotenuse. So sine 25 equals 20 over D. So D equals 20 over sine 25. So D equals 20 divided by sine 5, 47. 47.324 ... So to the nearest millimeter, that's going to be 47 millimeters is my answer. I can put OC equals 47 millimeters. Okay, that's, there we go. And another example. In many problems, the angle of elevation or depression is determined from the person's eye level and not from the ground. So you've got to pay attention to that. It's like when we did with the transit in the first example. In the diagram, the man is standing on the ground. He's 12 feet from the wall. So this is 12. And his eye level, oh, that's the angle of elevation. His eye is 6 feet. That's 6 feet above the ground. That's that distance. And his wife's level is 5.2 feet from the top of the building. So that means that this distance here is 5.2 feet down to there. And the angle of elevation told me that from the angle of elevation from his eye level to the eye level of his wife is 62 degrees. So this is 62 degrees. And find the height of the building. Okay. So the height of the building is going to be, this height is 6, and this is going to be what we're going to calculate here, and this is 5.2. So I'm going to set that up again, that I'm going to write the height of the building is 5.2 plus 6 plus D. So that's 5.2 plus 6 plus something, and then that equals something, and it's in feet. And there's my answer. Well, there's where my answer is going to go, right? Okay, and then just to make this a little bit simpler, I'm just going to redraw the part that I care about here, where I know this is 12. This is the D I'm looking for, and this is 62 degrees. Okay, and there's my angle of interest and my hypotenuse and my opposite and my adjacent. So I've got, that's going to be tan. So tan theta is opposite over adjacent, and tan 62 equals D over 12. So D equals 12 times tan 62, which is 22.5687. So I'm going to come up here to the nearest tenth of a foot. That's 22.6. And I throw all of that in my calculator, and I get 33.8 feet, and I'm finished that question. All right. All right, we need to talk about bearings. A bearing is measuring an angle clockwise from north. So north is 0 degrees. It's also 360 degrees because a circle has 360 degrees in it. So if it's gone 40 degrees from north, then it's just 40, although sometimes it's written as 040 degrees. This is just 3 other examples, 150, 225, and 330 is almost all the way around. Okay, we need that for the next question, which is a ship travels 6 kilometers from Port P on a bearing of 120 degrees. So I would draw this in pencil because this kind of question, you just never know where it's going to end up. I always tend to start it in the middle of the space I have available, and I always do it in pencil. Anyway, we know that this is 6 kilometers, and this bearing is 120 degrees. So let's just label that as 120 degrees. That's this angle here. All right, so it travels until it reaches Q as shown, and then it changes direction and it travels north until it reaches position R, which is due east of P. Due east means it's directly east. So that means that we're going to come across here, and this is point R. And how far east of point P is the ship? So we're looking for this distance here. That's what we're looking for. So to do that, well, we know that this is a 90-degree angle because this was due north and this was due east, so that's okay. How big is this angle going to be? Well, this is the angle. We have no way of finding this angle without knowing this angle because we don't know anything adjacent to it. But we can find theta because theta is going to be 120 degrees minus the 90 degrees because this angle here is 90 degrees. So theta is going to be this other little bit. So it's going to be 30 degrees. Okay. Now we've got a triangle that we can do something with. So let's just redraw that so that it's a little bit more clear. And I know that this is 30 degrees and this is the D I'm looking for, and this is 6. So we've got the angle HOA. I've got adjacent and hypotenuse, so that's cosine. So cos theta is adjacent over hypotenuse. So cos 30 is going to be D over 6. So D equals 6 cos 30, which is 5.196152423. So D to 1 decimal place is 5.2 kilometers. Okay. Then the ship continues going another 12 kilometers north for position S. So I'm going to do this in a different color on my diagram so that I know that this is part B. So I'm just going to go up here. This is 12 and it's going to point S. And now I want the bearing from S to P. Oops, that's not a very good line. And I'm just going to, well, I guess I need to figure out this angle. I'm not going to call it theta. I'm going to call it alpha this time. So this is alpha because I've already used theta. That's just another Greek letter, alpha. It's the first one in the alphabet. Ooh, alphabet. Okay, so let me redraw this down here where I'm going to do my calculations. So I have this distance is 12, this distance is d, which is equal to 5.2, and I'm looking for alpha. So I've got my angle, my hypotenuse, my opposite, and my adjacent. And then I've got, this is going to be tan. So tan alpha, or no, tan theta is opposite over adjacent, because I always start with that. And then I'm going to plug in what I'm using this time. So it's tan alpha equals 5.2, but it's actually not 5.2. It's, because I'm going to use this number. So it's 5.196 ... over my adjacent, which is 12. Now, I actually still have this number sitting in my calculator, right? Because I haven't done anything with that yet. It's still sitting there in all of its digits. So it's easy enough for me to do this. And I get that oops, I get alpha equals 23.4289 degrees. But alpha is not actually what I need. I need the bearing from point S. So I need to do another little bit of a drawing where I've got this, and this is my point S right here. And this is my alpha, but my bearing is going to be this whole thing. This is the bearing, right? Because it starts at north, and how far is it off of north? So my bearing is going to be 180 degrees plus my alpha. So that's going to be 203 degrees, rounded to the nearest whole degree. Or and then the three-figure bearing is 203. Okay, it's not just going to be the 23. All right, next question. This is the last one. If the ship maintains an average speed of 9 kilometers throughout the journey, determine to the nearest tenth of an hour the time taken for the journey. So where do I start on this one? Well, I know that speed, now when you're driving on the highway, I know you don't drive yet, but you know that speeds on the highway are in kilometers per hour, right? So that is distance divided by time. That is the speed. So that means that I can write that as S equals D over T. And if I solve that for time, then time equals distance over speed. And since I know that my speed is 9, I need to find my distance. And then I'll know that time equals something, and I'm going to have to round it probably, so it's going to be something hours. Okay, so now we can go and find D. Let's go over here and find D. So if I go back to my drawing, way up at the top, my distance is going to be 6 plus this distance. I'm just going to call that M. So D is going to be 6 plus M plus 12, right? That's, if I look at that, that's how far the ship has traveled. It goes 6 and then it goes M, and I don't know what that is yet, and it's going to go 12. Okay, so I need to find M. So that's going to be 6 plus something plus 12. And that's going to be something. Okay, so now I'm going to come down here and I'm going to find m. So I'm just going to draw that piece of the triangle because I don't want to have a whole bunch of clutter in my brain. I just want to know what I need to know. So I know that this is 30 degrees and m is what I'm looking for, and I know that this is 6. So there's my angle, my hypotenuse, my opposite, my adjacent. So since I've got O and H circled, this is going to be sine. So I've got sine theta equals opposite over hypotenuse. So sine 30 equals m over 6. So m equals 6 sine 30. So m equals 3. And that's exactly. And I probably would write that down for myself because I would be expecting a decimal and I want to know if I've rounded it. So anyway, now I'm going to take this 3 and that's going to go up here because that's my m. And then I'm going to go, oops, I didn't mean to write m. I meant to write 3. So it's 3. So 6 plus 3 plus 12 is 21. Oops, I want that in a different color just to show you what's going on here. Green. 21. Okay, so the 21 is D. D equals 21. So I've got to bring this over here and I can put the 21 there. See, I don't have to think about that anymore. I've already figured that out. And if I put that in my calculator, I get 2.3 repeating. 2.3 repeating is not the answer rounded to the nearest tenth of an hour. That is 2.3, okay? Repeating is not rounded, all right? Okay, that is it. And that's actually the last, that's the end of this. There's one more lesson in trigonometry, but this is the end of lesson 6. All right, okay, bye.